unit circle, knowing where the asymptotes are, we know that the tangent function starts at pi over 2 based on where those asymptotes are, that it starts at pi over 2 and goes to 3 pi over 2 for the parent function. We also know from our exploration that the sketch looks something like this. And so we're going to make a table to get one period from pi over 2 to 3 pi over 2. Or actually, if those are the asymptotes, I could actually start at negative 3 pi over 2 to pi over 2 to get one on both sides of this. So we're actually going to start at negative pi over 2. Now, with sine and cosine, we only used quadrantal angles. Should I only use quadrantal angles for tangent? No. What other? For secant and cosecant, we will want the 30-degree intervals, but for tangent, we're going to want the 45-degree intervals. So we're also going to need negative pi over 4. So these will be our x's for our parent function of tangent. Yeah, I forgot positive pi over 2, thank you. Yeah, that's what this is supposed to be, positive pi over 2, not pi. So those are our asymptotes, and those are the values in between. So when we do this, if this is negative pi over 2, and this is pi over 2, we know that pi over 4, positive pi over 4 is 1. Negative pi over 4, the tangent would be negative 1. Undefined gives us the vertical asymptotes. And the tangent of 0 is 0 over 1, which is 0, all from the unit circle. So for the parent function of tangent of x, this is what one period looks like. One period looks like this. I could have also done this from pi over 2 to 3 pi over 2. That would be the next period. So we can plot these pretty easily. We have 0, 0, pi over 4, 1, negative pi over 4, negative 1, and then it's going to approach the asymptote as it curves upward, approach the asymptote as it curves downward. Any questions on that? So that's our parent function. That's only one period of our parent function. So if we need 2 periods, we should do the next one from pi over 2 to 3 pi over 2, if we needed to. So the equation of this one, since it's our parent function, is f of x equals tangent of x. How long is the period for tangent? Yes?
So is the only difference from these notes from the other ones is that we're dealing with tangent instead of sine cosine?
So in terms of phase shift and amplitude and all these things affecting the graph, yes. We're going to do the same things to x to change our x coordinates, the same things to y to change our y coordinates. We just start with a different parent function, yes.
Will they tell you whether it's tangent?
They're going to, so if it's, when I ask you to graph, I will tell you what function you're graphing.
Okay.
It'll say tangent of 4x, like example 1 is going to be. So you'll know which function you're supposed to, which parent function to start from. When we do some application problems, which we'll get to next week, you'll look at a graph and decide whether sine or cosine would better fit it, or tangent, or one of the other ones, and then figure out what equation to write. So in that case, I'm not going to tell you the function. Okay. All right, so period of a tangent function is not 2 pi. It's 1 pi. It's just pi. So it's actually pi over b. Just like for sine and cosine, it was 2 pi over b. So that's the period for a tangent function. And for us, for our parent function, it ranged from negative pi over 2 to pi over 2 for our parent function. Locate the vertical asymptotes, state the period, and the sketch of 2 periods of each function. We need to know there's going to be infinitely many vertical asymptotes, and they're going to happen every pi units, right? It happened at negative pi over 2, now it's going to happen at pi over 2. The next one's going to happen at 3 pi over 2, okay? They're all pi units away, but if you look at the top of your unit circle, right, there's pi over 2, here's 3 pi over 2. Anytime you come around the unit circle and you hit one of those, you have a vertical asymptote, and those are pi units away. So the equation for the tangent lines, or for knowing where the tangent lines are going to be, is going to locate all vertical or the vertical asymptotes. The vertical asymptotes for this one are going to be, now first off I gotta check to make sure there's not a vertical shift, or not vertical, a phase shift. If there's a phase shift, it'll change, right?
Yeah.
There's no phase shift. Since there is no phase shift, it's gonna be pi over 2. There is a 4, which is gonna change it also, right? So we should talk about that for our parent function, and we can adjust it in a second. So for our parent function, it's gonna be at pi over 2. Our vertical asymptotes will all be at pi over 2 plus pi times n, where n is an element of the integers. So that could mean pi times negative 1. Okay, well that's pi over 2 minus pi. That's negative pi over 2, which is what we have right here. You could add 1 pi to it. That's going to give you 3 pi over 2 to get your next asymptote. But this will change because of the 4, because our period, is our period going to get longer or shorter when b is 4?
Shorter.
Shorter. Because, so before we write this, we may want to state the period, which is going to be pi over 4. Okay? The asymptotes then, it's not pi units away, right? Before they were pi units away, but now the period isn't pi anymore, it's
1.
pi over 4. So, let's look at how to do that in a second. Let's graph it and we'll come back and write it out. Can you do the top still?
Yeah.
Okay. We'll get the formula for the rest of them in a second. We'll see if you guys can figure it out as we graph this and see what happens with the graph. So, let's make our table. We have our regular function, which we have above, for x and y for the tangent function, which starts at negative pi over 2, negative pi over 4. They ask for 2 periods, so we'll deal with that in a second. 0, pi over 4, and pi over 2. And we had undefined, negative 1, 0, 1, and undefined. There's our parent function. Well now, nothing happened vertically. There's no amplitude, so no vertical stretch or compression, no vertical shift up or down. But the x-coordinate changes. What do I need to do to the x-coordinate?
Multiply by
1/4 of the x-coordinate. So this becomes negative pi over 8. This becomes negative pi over 16. That's 0. This becomes pi over 16 and pi over 8. Well, those were equally spaced before, right? On the original x, they were all roughly pi over 4 units apart, or 45 degrees apart for each of these. So since they're equally spaced, these will also be equally spaced when I go to plot them. So I could make this the pi over 8 if I want, and then this is the pi over 16 because it's half of pi over 8. Here's the negative pi over 16 and the negative pi over 8. So those are evenly spaced. And then these will be evenly spaced over, right? This will be pi over 4, 2 pi over 8 on this one if I go to do another period beyond it, which we'll do in a second. So we are going to plot the same thing. We have pi over 8 as undefined and negative pi over 8 as undefined. Oh, that's not what I wanted.
We have to graph the parent function too.
No. Only if they give you f of x and g of x and say to graph the functions, then you'll do it to compare them, but right now, no. So then I have 0, 0, and I still have this one at 1 and this one at -1 because there was no reflection across the y-axis. So here's one period of tangent, and that's occurring at pi over 16. Before it was occurring at pi over 2. So how would I have figured out that it's now pi over 16 if before it was pi over 2 and now it's pi over 16?
Wait, why is it pi over 16? Like, is it, like, you don't count pi over 8?
No, I'm sorry, that's not, it is pi over 8, I'm sorry. I'm looking at these points and saying the wrong thing. It is pi over 8, you are correct. That's where the asymptotes are. Before it was pi over 2, now the vertical asymptotes are at pi over 8, right? Are they going to be every pi units apart? What's our period?
Pi over 4.
They're going to be every pi over 4 units apart. So pi over 8 plus pi over 4 times n. We now know where one of the vertical asymptotes are, our first positive one, and we know the period is pi over 4. So here's what happens. If you know the period, that's what you're going to add on times n. And originally it was pi over 2, so how would they have gotten the 8? Times it by b. By the reciprocal of b, the horizontal compression of 1/4. So you can find it that way. You can also just find it by finding these and knowing what the period is. So this one, what do we expect here? We're going to have a longer period. Instead of a period of pi, it's going to be, what's up?
Only one period?
That was only one period, thank you. So we got to sketch another one. Because I have work over there on that side, I'm going to go this way. This is we have 1, 2, 3, 4. 1, 2, 3, 4. So this is 1/16, 2/16, 3 pi 16ths, 4 pi 16ths, which is pi over 4. You can leave it in terms of 16ths or in terms of 8ths if you want, if you're going to do this one. 1, 2, 3, 4, 5 pi over 16. 6 pi over 16, which is 2 pi over 8. Right? If this was pi over 8, then this is going to be 2 pi over 8. So if you just wanted to label the 2 pi over 8 and the pi over 4 in between, that's fine too.
So pi over 4.
Oh yeah, pi over 4. Then this one was pi over 8, no? 1, 2, 3, 4 16ths is pi over 4. Oh, this was 1, 2, 3, 4, 5, 6 pi over 16 is 3 pi over 8, sorry. 3 pi over 8. All right, so we have our vertical asymptotes in blue, so this one's going to be another vertical asymptote. This is easy because now I've just got the 3 intervals between. This one's up at 1, this one's down at -1, and this is at 0. So I can just connect those. There's a second period. You could also go in the negative direction if you prefer to do that.
I don't get how you like got that.
Oh, I got the other points?
Yeah.
Okay, it just repeats itself. It's going to repeat this pattern because it's like the parent function, since there haven't been any reflections over the x or y axis. What I see is to the right of the first vertical asymptote, it goes down from this point. In the middle, it's at 0, and on the right, it's at 1 next to the rightmost. And that pattern is going to continue for every period. So I just have to get my axis labeled and then plot. Or if you really want, you could plug those numbers, right? You could extend the numbers further. And then go around the answer. The other thing you could do, if you don't like that, you could have gone from pi over 2 all the way down to 3 pi over 2 and done those, and you would have seen the same thing, right? It would have all happened at once in your table instead of trying to figure it out afterwards.
Yeah.
And then you would just plot it and not worry about it. So we could do that for the next one if you guys prefer doing that. For tangent of x over 2, only one thing has happened. This is a horizontal stretch of 2. So instead of our period being pi, our period's going to be 2 pi. Sorry. How do I find which one? I couldn't hear you. The period. So remember, it's pi over b. So period, it would be for sine and cosine, it's 2 pi over b. For tangent, it's pi over b. So since b is 1/2, I'm going to multiply by the reciprocal of 2 over 1. That's how I get the 2 pi. The frequency would be 1 over 2 pi. Yes?
I thought you had to do like the three, like on the first row, but I thought you had to do like the 3 lines, because it's like the middle is 1 and the 2 sides are like half. So don't you have to do like 3 lines? Like you said, it's not like,
This is our first vertical asymptote right here.
yeah.
This is our next one. And there's 3 points of interest between them. The one that's at 0, the one that's at -1, and the one that's at here. We're going to make a table all the way to 3 pi over 2 this time to get 2 full periods, so that you don't have to worry about figuring that out afterwards. So here's our original parent function. We're actually going to go from -2 pi, or from negative pi over 2 all the way to 3 pi over 2 for our original parent function. So we have pi over 2, or negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi. Is that right? What did I miss? Pi over 2, 3 pi over 4, pi. Okay, 5 pi over 4, 3 pi over 2.
Why you just
Why am I doing this? Why am I doing a bigger table this time?
These are from your line.
Thank you. So why are we doing a bigger table this time? So I can get 2 full periods. So remember that 3 pi over 2 and negative pi over 2 are coterminal. So from going from negative pi over 2 to pi over 2, I've completed one period. And then to go from pi over 2 to 3 pi over 2 completes the second period. And that's all done on the table, so I don't have to try to figure out how to scale the axis at the end. It's already done through my calculations. So we know that this is undefined. This is -1, 0, 1, undefined. You'll want to check on your unit circle. 3 pi over 4 is also -1. The pattern's just going to keep repeating. 0, 1, and then undefined again. Yes. You'll be able to sketch one. I'll double check for you. You'll be able to sketch one or quickly grab the values. Here's the thing though, you already know sine and cosine because you've graphed it so much. So you know the parent function for that. In your practice, by writing this table every time and starting with it, you're just going to know, oh, it's always undefined, -1, 0, 1, undefined. There's a pattern to it. So we have x and y. And the x, we said it's a horizontal stretch of 2, since b is 1/2, so we have to do 2 times x. Well, that keeps this undefined, so everything that was undefined stays undefined. Everything that was 0, since there's nothing added, stays 0. Oh, it's the x. Thanks. So this becomes negative pi. That makes more sense. This becomes negative pi over 2. This stays 0. It's doing this. I can just leave it here. That's fine. We'll graph it in a second. This becomes 0. This becomes pi over 2 and pi. This one's going to become 3 pi over 2. That one's going to become 2 pi. This one's going to become 5 pi over 2. And this last one will become 3 pi. So just by multiplying everything by 2 on top. And those are still equally spaced. They were all equally spaced by 45-degree intervals. Now they're all equally spaced by 90-degree intervals. So I have to make sure I fit a 3 pi on here. I could just extend my graph out if I have this as pi and this as 2 pi. And I'll just bring this over a little bit more to get me to 3 pi. In between I have the pi over 2, the 3 pi over 2, the 5 pi over 2. And don't forget about the negative pi over 2 and the negative pi. So we plot these points. Not working. Okay. So now we have our asymptotes at negative pi, at pi, and at 3 pi. Here we go down to negative 1, 0, 1. Negative 1, 0, 1. So the asymptote is now at pi. 3 pi and negative pi. Yes?
So can we do it like either way you did it the first one or the second one?
You could do that. Yeah, if you are good at equally spacing them and you're like, oh, this is easy because that was pi, so my next one is going to be 3 pi.
So we don't have to write out all this.
You could just write the first period if you can do it that way, but you still have to scale your axis, so you want to make sure that if you try to do it afterwards and it's not working, you'll go back to the table and finish it that way. There was another question. Was that your question, Courtney?
No, I figured that.
Okay. So there's 2 full periods of this. The one thing I think we forgot to do was state the period, which we already did, but we also were supposed to state the vertical asymptotes. Right now they're happening every pi units. So the vertical asymptotes are at pi plus pi
2 pi.
plus 2 pi, because that's the period, plus 2 pi n.
Wait, so
So the vertical asymptotes are wherever they are plus the period times n. So for any function, the vertical asymptotes are going to be wherever they are from your graph plus the period times n. Yes, sir.
so for sketching 2 periods, can we just go from negative pi over 2 to
3 pi over 2. That's what I did on the graph. So you can always start with this, and then it'll automatically happen that you'll have all the values to fully scale your axis.
Yeah.
And then you don't have to worry about, wait, where do I put the other ones?
Yeah.
That might be wiser.
For the last one.
Yep. But you could do it the other way as well. All right, locate the vertical asymptotes, state the period, phase shift, vertical shift, sketch 2 periods of each function. Well, okay, this pen's driving me nuts. All right, so what do we have for our period? First off, I don't like to look at the function this way. Some of you guys do. What should I do?
Take out 1/3.
Factor out the 1/3. So I have negative 2 tangent of 1/3 by x plus, well, if I multiply pi over 6 by 3, I get pi over 2 minus 1. So right now we have a vertical shift of down 1. We have a phase shift of left pi over 2. We have a horizontal stretch of 3. So in terms of what I'm going to do to x, I'm going to have to do 3 times x. Because of this number right here, we're going to do 3 times x minus pi over 2 to get our new x coordinate. To get our new y coordinate, we're going to do negative 2 times y minus 1 because of the,
What is that for?
which one?
What is that?
That's a pi over 2. Negative pi minus pi over 2.
Is the phase shift negative pi over 2?
The phase shift is, yes, what we see in the parentheses is counterintuitive to what we expect. So this is going left pi over 2, so the phase shift is negative pi over 2. Just like this 1/3 doesn't mean I'm going to multiply x by 1/3, it means I'm going to multiply it by 3. Our period, did they ask for the amplitude? No, that's not. Amplitude would be 2. Our period is going to be 3 pi. Because it would be pi over 1/3 multiplied by the reciprocal, 3 pi. So we'll start with our table for tangent. Negative pi over 2, negative pi over 4, 0, pi over 4, sorry, yeah, pi over 2, 3 pi over 4. Some of you will want to do it this way, some of you will want to extend it afterwards. Pi, 5 pi over 4, 3 pi over 2. And our y's, I'm going to actually put our original y's over here because I know I'm going to do two things to the x's. I'm going to put my original y's over here. Would have been undefined, negative 1, 0, 1. Undefined, negative 1, 0, 1, undefined. So those are my original x and original y, and I have to transform them. So for the x, we're going to multiply by 3 and subtract by pi over 2. So this one becomes negative 3 pi over 2 plus pi over 2, which is negative 2 pi over 2, or just negative pi for my x. I would have written it up here. This is what we're doing to each x, multiplying it by 3 and subtracting it by pi over 2. This one, when I multiply by 3, I get negative 3 pi over 4. If you want, you can convert all of these to fourths if it helps you to equally space your axis. We already know that they're equally spaced because they started out equally spaced. In terms of fourths, adding pi over 2 is really adding 2 pi over 4. Because I multiply the top and bottom by 2 to get the denominator to be 4.
I thought we're subtracting.
We are subtracting, thank you. No? Wait, yeah, we're supposed to subtract, so I have the wrong answer, don't I? Okay, we have to fix this, sorry. So this should have been minus pi over 2, which would be negative 4 pi, so it would be negative 2 pi. Negative 3 pi over 4 minus pi over 2 is minus 2 pi over 4, which becomes negative 5 pi over 4. Zero minus pi or times 3 is 0. Minus pi over 2 is negative pi over 2. Pi over 4 minus 2 pi over 4 is negative pi over 4. I forgot to multiply by 3. So 3 pi over 4 minus 2 pi over 4, sorry, is pi over 4. That's going to be 3 pi over 2 minus pi over 2 is 2 pi over 2, or just pi. 9 pi over 4 minus 2 pi over 4 is 7 pi over 4. Pi minus pi over 2 is pi over 2. No, 3 pi over 2, thank you. Because it was pi. No, it's wrong. It's 3 pi minus pi over 2. You gotta remember to multiply by 3 first. So that's going to be 2.5. So 5 pi over 2. Or 2.5 pi. Careful with the decimals because it's not just half units on all of these. And then this last one's 15 pi over 4.
13 pi.
Is that a 3 or what is this? I'm not on the last one, I'm on this one. 15 pi over 4 plus 2 pi over 2, 7, or 2 pi over 4. Is that 17 pi? No. Yeah, 7. Left. Subtract, because we're subtracting, sorry. So it was 15, subtract 13 pi over 2. Geez, get my operations right today. All right, and then we have 9 pi over 2 minus pi over 2 is going to be 8 pi over 2 or 4 pi. It should be 13 pi over 4, yes. Thank you. All right. Now, that was a little bit of a mess. The y isn't going to be as bad as that.
Nope.
Isn't going to be as bad because we're just going to take those and multiply them by -2 and subtract 1. So I'm going to do times -2 minus 1. So this stays undefined. This becomes 2 minus 1 is 1. This was 0 minus 1 is -1. -2 minus 1, undefined. This pattern should repeat, right? It's the same numbers again. So 1, -1, -3, undefined. So we have our final x's and final y's. We just have to scale the axis. It's not working. All right. So we're going to scale our axis, and we start at -2 pi, but it goes up to 4 pi. So I probably want this to be the 4 pi. Then I'll have pi here and 3 pi here, -1 pi and -2 pi. You can scale it differently if you want to. But I was looking at what our max x is and our minimum x to scale it. So this is this our final numbers here for x? Yes. No. Where did half of them go? Oh, they're down here. I have no idea what just happened there. Oh, this is my final answers for x on this side, and then this is the rest of them. All right. So if -2 pi is undefined, those should still be equally spaced. I can put my other undefined values. That's at pi. Sorry?
I'm on the second thing,
The -5 pi over 4.
yeah, isn't that past?
It's halfway between.
No.
It's 1.25 pi.
Oh,
But these are all evenly spaced between. So if you know where -pi over 2 is, you're going to put it halfway between. Hold on. So we're going to do this. We have I want to put the asymptotes in first. So we have pi, and the other asymptote is 4 pi. So now I just have to have my intervals between these. Right now I have that's pi. These are all pi units apart. So now when I go to -5 pi over 4, that's a little more than pi. It's actually halfway between. No, it's not halfway between, is it? Right? What is that? 1.25? So it's halfway between halfway. And that's supposed to be -1. Positive one, I'm looking at the wrong thing. And then -pi over 2, if this was pi, then pi over 2 is here, and that's at -1. Pi over 4, positive pi over 4 is, that's pi, there's pi over 2 halfway between these. That's supposed to go down to -3. Why is this opening the other way? Because it was a reflection over the x-axis because of the -2. It looks more like which function? Not tangent, but cotangent. So cotangent looks like this graph. And then we have the other one, which is that 7 pi over 4? That's almost 2 pi, but not quite. That goes up to 1. 5 pi over 2, that's 2.5 pi. That's at 0, or not 0, negative 1. Yeah. 13 pi over 4, that's just past 3 pi, and that's negative 3. All right, any questions on graphing that? The vertical asymptotes are, our first one's at pi, and then our next one is how many? What's the period? The period was 3. So the vertical asymptotes are going to be pi plus 3 pi n. Will be all, the first positive one plus 3 pi n.
I have a question.
Yes?
On the test for writing vertical asymptotes, do we have to like write that with the checkpoints right where they are?
That equation accounts for all of them across like
Yeah.
infinite periods. So yes, it should be that equation for them. Not just the ones that are on our 2 periods, but the ones that accounts for all. Okay. Just like the amplitude accounts for all of the graph. So give letter B a shot. See if you can at least find all the parts you're supposed to find and get the correct table.